Hello students, in our session on sedimentation, we have understood the concept of the sedimentation, how the process is taking place and what are the conditions that affects the process of the sedimentation, and also we learned some design on the sedimentation tank. As we know, it in a typical sedimentation tank, we say it as a old and outdated because it works under the natural condition, that is it requires large area in order to make the velocity slow, and also it requires large amount of the detention time, that is actually a waste of time for us, and also we have to wait a lot of time has to be given in order to clean and also for the maintenance of the sedimentation tank. In order to overcome these disadvantages of the old and outdated method of the sedimentation, we came across with the new types of the settlers or the sedimentation tanks, which includes, and we call them as plate settlers and also the tube settlers. So these are some of the concepts that overcome the disadvantages that is brought by the typical sedimentation tanks or the old method of the sedimentation tank. So in 1904, the scientist Alan Hazen proposed that, so if we are going to decrease the depth what we are considering for the sedimentation tank, there can be a very good economy that can be brought in saving the area of the tank, and also we can achieve a easy sedimentation. As we are reducing the depth, the length of the travel for the settling of the particles becomes less. In order to achieve this, it is very difficult. Why? Because in typical sedimentation, we know we have to increase the area in order to make the velocity slow. So to overcome this, we have to when we decrease the depth, we have to increase the area of the contact. See, in typical tank, we know this is the only area that is coming under contact. So particles will be coming down and settling down under the gravity. So by the methods of the plate settlers and tube settlers, we are changing the process. This empty tank, which was kept normal, because of this the particles would have settled down like this slowly. Now we are replacing this tank which was empty with the plates and the tubes. So in case of the plate settlers, a series of plates which are slanted are at a sloped at a degree of around 55 degrees. So they will be sloping. So now this arrangement of the plates is placed inside the tank. So water is made to rise through the bottom orifices which are provided. It rises up and it will be collected by the common collection channels that will be connected to the plates. So from here it will be taken out further for the next process. This is in case of the plate settlers, that will be studied in detail further. In case of the tube settlers, instead of plates we are going to now give the tubes. A series of tubes like this will be given, a cluster or a group of tubes that will be fitted. This entire mass is fit into the tank. These are also sloping around 60 to 66 degrees slanting. Here in this case the flow was coming from downside to the up, but here since they are slanting, for example let us take one tube. Here we can see, so water gets entered here. So particles try to settle down here itself since it is slanting. So because of the gravitational pull, since it is slanting, so just they slide down and get settled here. So if it was normal, the mechanism would be like this. Now because of the presence of the tube, the process of the sedimentation has very much advantages, since many of the companies are giving us the ready-made cluster of the tubes or the plates that are available, and also the existing system can also be modified for the new one as by including the plate and also the tubes inside the existing tank. These are very advantageous and the upcoming technologies, and they look compact since we are reducing the area also. They can be learned now. Here the figure shows a typical plate settlers, and these designs generally provide more equalized flow through the plate sections. The series of plates are arranged, and these will be arranged inclined at certain angle around 55 degrees to the horizontal, and a common flow collection pipe or a channel is provided commonly to two of the channels. So here we can see, because of the arrangements here, the cleaning operation and also the maintenance inspection Other things are very easy when we compare this with the typical sedimentation tank. And also the design features here includes variable sized influent flow distributors. Because of this, it facilitates us to treat how much of the water we want and increase the rate of the treatment. And also the utilization of one collection tube for two different flow channels. That is a main advantage here. And here in this case, the flow passes from the bottom by using a small inlet orifices, and it rises up to the settling zone, and it proceeds upwards through the plates. As it rises upwards, since only the water can rise up against the gravity, the particles cannot rise up. They settle down in the settling zone itself. And here, but careful attention has to be given in order to maintain proper design velocity in order to achieve a good amount of the settling. And the effluent that is collected uniformly at the top of the plate sections, here you can see the water is collected or the effluent is collected. The effluent or the water after settling or removal of the particles is collected from the plate sections, that is passing through the orifice at the bottom now into the collection tubes, ensuring stable flow and maximizing the settling. And the flow passes out of the collection tubes and over the wear plates connected to the stainless steel connection troughs. And only one advantage with this is generally these are made up of the stainless steel body. Because of that, we can expect a longer life when we compare to the tube settlers, and the maintenance is very much low. And when we compare this with the regular sedimentation tank, maintenance, cleaning, and other operations inspections are also very easy. Here we can see the next step of the settler, that is a tube settler. Just like we took up one extra component, that is a plates inside the tank in case of the plate settlers. Here now we are providing a series of the tubes or multiple tubular channels which are sloped at around 60 degree in this case in order to enhance the settling rate. And these tubes are provided adjacent to each other. This entire mechanism is done inside a tank, and these are more effective when we compare to the plate settlers, since this provides for a particle a settling depth that is significantly less than the settling depth in the conventional clarifiers, and also it reduces the settling time. So here one arrangement is being seen. Here we can see a series of tubes are provided. Here in this figure we can see various tubes that has been provided. Inside these tubes the water will flow, and then it is taken for the settling. So here the figure shows the conventional settling compared with the lamellar settling. In case of the conventional settling, this is the arrangement. A simple tank will be there, and water will be made to rest for some time, and particles will come down with respect to time and settle to the bottom. Here, what is the difference we are making? We are providing a tubes. Because of the tubes, increased area is provided for the settling. These are also sloping to some angle around 60 degree. Because of that, the particles that settles at this point cannot stay for a longer time. They have to slide down to the bottom. With this effect, more amount of the particles will be settling to the bottom. This is the idea behind the tube settlers. And these can capture the settleable fine flock that escapes the clarification zone beneath the tube settlers, and it also allows the large flock to travel to the tank bottom in a more settleable form. The tube settlers channels collects solids into a compact mass which promotes the solids to slide down to the tube channel. But when we compare to the plate settlers, cleaning of this is quite difficult. And but apart from this, it has a many advantages when we compare with the others, such as these clarifiers when equipped with the tube settlers can operate 2 to 4 times when we compare the normal rate of the settling or clarifiers. So it is possible to cut the coagulant dosage up to around half for maintaining the lower influent turbidity. So it has two advantages. Both it reduces the area that we require for a sedimentation tank, and also it has an added advantage of reducing the coagulant dosage. And also already existing systems of the sedimentation can be retrofitted and converted into a tubular or also plate settlers. And it requires less filter backwashing because of the tube settlers, which means it reduces the load in the upcoming unit, that is on the filters. And tube settlers increases the allowable flow capacity by expanding settling capacity and also increasing the solid removal in the settling tank. It has many advantages when we compare with the regular sedimentation tank. And also, due to their high efficiency, the size of the basin can be reduced to around 2 times when we compare with the tube settlers, or when we compare with the regular settlers. And disadvantages with this is it needs a special design and also the installation. This is not like regular construction of the sedimentation tank. Some skilled supervision and also labor work is required, and also initial investment for both plate settlers as well as tube settlers is quite high. Now, as specialized designs are available from many companies that we can easily incorporate, and ready compact units are also available for treating the water, so that some individual plants can also be operated easily.